Good morning, dear students. My name is Ferhan Mazher. The subject today we are studying is Cambridge O Levels Physics 5054. Today we have selected October-November 2023 1-1 paper. This is MCQ paper. The time allowed for this paper is 1 hour. There are 40 MCQ questions and we have to choose the right option from the given four options. So let's start today's paper. So here is this paper, October-November 2023, 1-1 paper. This is the latest paper. So here we go. The first question is showing up on your screen. Which description is of a scalar quantity? Scalar quantities are those physical quantities which can be described and explained and understood and described by their magnitude only. There is no need of the direction. So it has a direction only? No. It has direction and unit only? No. It has direction, magnitude, and unit? No. It has magnitude and unit only. I think that the D is the right option, sir. Okay, so question number one, I think it's D part. Question number one, it's D part is the answer. This is the marking scheme. You can see the marking scheme. So, question number two, the diagram shows a distance time graph for a car traveling in a straight line. In which region is the car decelerating? So it's a distance time graph, and you know the gradient of the distance time graph represents the speed. So wherever the car is decelerating, the gradient will be decreasing. So if you look at here, the gradient is increasing. Here, the gradient is constant. Here, the gradient is decreasing. Here, the gradient is increasing. Here, it is constant. Here, it is decreasing. Here, the gradient is zero. So where it is decelerating, where the gradient of the distance time graph is decreasing. So I think C is the right option, sir. I think C is the right option, and our option is right. Question number three is showing up on your screen. So he says a wooden block is pushed across a table at constant speed. Which statement is correct? So here we have a pushing force. It's a wooden block. It's on the table. So it's dragging on the table. Which statement is correct? The frictional force increases as the block moves at a constant speed. That is not, the frictional force is equals to the pushing force, and the resultant force is zero. Why I'm saying so? Because here it says that the speed is constant. If the speed is constant, that means that the resultant force is zero. That means that the forward force and the backward force, the pushing force and the frictional force, they are equal to each other, and the resultant force is zero. So the frictional force increases as the block moves at a constant speed. That is wrong. The frictional force is equal and opposite to the pushing force. This answer is very promising. The frictional force is greater than the pushing force. The frictional force is less than the pushing force. B is the right option, sir, because the body is moving with a constant speed. So that means the resultant force is zero. The forces are balanced. Question number three, B is the right option, sir. Our answer is right. Question number four. He says a car begins to move. It speeds up until it reaches a constant speed. What happens to the acceleration and what happens to the velocity of the car? Because the car is speeding up, that means its velocity is changing, and then it becomes first it speeds up, then the speed becomes constant. That means its acceleration is also changing. So both the acceleration and velocity, they are changing. Yes, that is right. Only the acceleration changes. No, speed is also changing. Only the velocity changes. No, the acceleration is also changing, because before there were some acceleration, and then the acceleration becomes zero because the velocity becomes constant, the speed becomes constant. Neither the acceleration nor the velocity changes. That is wrong. So I think A is the right option, sir. Both the acceleration and the velocity change. Question number 4, A is the right option. Okay, so we are going to the next question. The next question is question number 5. The diagram shows how the length of a spring changes when a load of 10 Newton is suspended from it. The 10 Newton load is replaced by a 20 Newton load. What is the new length of the spring? Okay, so here we have a spring. Its unstretched length is 5 centimeter. When we put a load of 10 Newton, the stretched length is 8 centimeter. You know, the extension is, we can find out the extension. And the formula for the extension is stretched length minus unstretched length. So 8 minus 5, that is 3 centimeter. So I'm going to use the method of proportion. So load and extension, when the load is 10 Newton, the extension is 3 centimeter. And when the load is 20 Newton, we don't know how much is the extension. So let's suppose that is X. So 10 by 20 is equal to 3 by X, cross multiply. So X will be equals to 3 into 20 divided by 10, and that will be 6 centimeter. So when you have put 20 Newton load, the extension will be 6 centimeters. So what will be the stretch length when 20 Newton load is hanging with the spring? So that will be L equals to L naught plus the extension, and that will be unstretched length is 5 and the extension is 6. So 5 plus 6, that will be 11 centimeter. So I think 11 centimeter. Do we have that option here? Yes, and that is the B choice. 11 centimeters. So we think question number 5, B is the right option, sir. Question number 5, B is the right option. Okay. So let's go to the next question. The question number 6, he says a force F causes a moment about point O on a L-shaped bar. The force F acts at point P. What is the moment of the F about the O? Okay, so here this is the force is acting here at point P, and this is L-shaped bar, and the pivot is here at O. The pivot is at point O. So if you want to find out the moment produced by this force F, that will be equals to the force multiply the perpendicular distance between the line of action of the force and the pivot. So the force is here. So its pivot is here. So the perpendicular distance between the pivot and the line of action of the force, this is the line of action of the force. The perpendicular distance is this one. This is not the perpendicular distance between the line of action of the force. This is not the perpendicular distance between the line of action of the force and the pivot. This is that distance, which is perpendicular to the line of action of the force. So this is the distance between the pivot and the line of action of the force, the perpendicular distance. So the moment produced by the F about the point O will be F multiply D4. F multiply D4. So we think D is the right option. Question number 6, D is the right option. Question number 6, D is the right option. So here I have done this on paper also, you can see, but the real explanation is here. Okay. Question number 7. A uniform meter rule of the weight W is pivoted at 25 centimeter mark and held horizontal by a force F applied upwards at 100 centimeter mark. The rule is supported by a vertical force P acting at the pivot. So here you have that pivot, and this is at 25 centimeter mark. Here is the center of the gravity of that rule. So here the weight of the rule is acting. Its distance from the pivot will be 50 minus 25, that is 25. And here you have applied a force in the upward direction, and its distance, perpendicular distance from the pivot is 100 minus 25, that's 75. Because the rule is the meter rod is in balance, so the clockwise moment produced by this weight is equals to the anti-clockwise moment produced by this force F. Okay, so because the clockwise and anti-clockwise, they are equal to each other, so the clockwise moment is equals to the anti-clockwise moment. So weight, that is the force, the into the 25 centimeter is equals to the F multiplied 75. So the F will be equals to 25 divided by 75 of the W. So that is 1 by 3 of the W. So the F is 1 by 3 W. So here in their question is, what is the magnitude of the P? Because this whole meter rule is in balance. So for balance, there are two conditions. First condition is that the forces are balanced. And the second condition is that the moments are balanced. So according to the first condition, the downward forces and the upward forces, they will be equal to each other. In the upward forces, there are two forces, P, which is the reaction at the pivot in the upward direction, and F, which is in the upward direction, and the downward force is W. So P plus F will be equals to W. So here you can see P plus F is equals to W. So in the place of F, I can write in the terms of W, I can write 1 by 3 W. So P plus 1 by 3 W is equals to W. So P will be equals to W minus 1 by 3 W. So I will do the mathematics. So the P will be equals to 2W by 3. Or you can say 2 by 3W. So the P value will be 2 by 3W. 2 by 3W. Their question, what is the value of the P? It's a little tricky question. Let me show you the solution once again so you can have so this is the solution, how this is done. First of all, we have found the F in terms of W, and then we have used the first condition of the equilibrium, that the forces are balanced. So the upward forces are equals to the downward forces. The upward forces are P plus F, and the downward force is W. So I hope you understand. So we think that C is the option. Question number 7, C is the right option, sir. Okay, so we are going to the next question, and the next question coming up on your screen, that is question 8. The diagram shows a stationary fairground ride with the 4 chairs of equal mass. Which chair has the most gravitational potential energy? You know, gravitational potential energy, that its formula is mgh. So the chair, because they all have the same mass. So, and the gravitational potential energy formula is mgh. So the chair which is at the highest level from the ground, that has the largest gravitational potential energy, the most gravitational potential energy. So we think that A, because it is at the highest point. So I think question number 8, A is the right option, sir. Question number 8, A is the right option. Okay, so we are going to the next question. Question number 9. Hydroelectric and tidal power stations generate electric energy. Do these use renewable source of energy? Hydroelectric is a renewable energy source. That's true. Tidal power is also a renewable energy source. So yes, yes. So that is the D option, I think. Question number 9, D is the option, and that is right. Question number 10. Which energy resource is correctly described? Energy resource and renewable or availability. Biofuels, they are renewable, yes. Availability at all the times. And nuclear, renewable, yes, that is wrong. The nuclear is not renewable. And solar radiation, renewable, yes, it's renewable. And its availability is at all the time, that is wrong. So C is wrong, B is wrong. Wind, is renewable, yes, it's renewable, but he has written here no, and it says its availability is intermittent. So the B is wrong, C is 100% wrong, D is wrong. Okay, because wind is renewable. It's not non-renewable. So it's renewable. So C, D wrong, C wrong, B wrong. So the only right option we are left with is option A. Biofuels, yes, they are renewable. So we think question number 10A is the choice. You see how tricky? We just ruled out all the wrong ones, and then we are able to tell. Okay, question number 11. A small motor has an input power rating of 10 watt and is switched on for 5 minutes. What is the electric energy input to the motor in this time? You know, the energy is equals to power multiplied time. Um, the power will be taken in watts and the time must be taken in seconds. So 5 minutes, you will convert that into seconds, and then we will be able to find that. Okay. So here we have question number 11. I have done this on the paper, so I hope energy is equal to power multiplied time. So 10 multiply 5 multiply 60, because I have converted that time into seconds. So it will be 3000 joules. Let's see. 3000 joules. D looks the right option, sir. I think question 11, D is the option. Yes, that is right. Question number, now we are on the question number 12. He says, two liquids, X and Y, are poured into beakers of different sizes. Liquid X has a density of 1000 kg per meter cube, and liquid Y has a density of 900 kg per meter cube. On the basis of which beaker is the pressure greatest? So, on the base of the beaker, you know the pressure of the liquid is rho GH, rho GH. So that beaker will have and the pressure will be the greatest at the base, which has the largest or highest density and whose depth above that base is largest. So because the liquid X has the higher density, more density, and in the figure C, you can see that its depth is greatest also. Here, they both have the same heights, but because its density is more, so here its pressure will be the greatest at the base of the liquid. The pressure of the liquid depends upon the density of the liquid and the depth of the liquid above the point of observation. So, in the figure C, the pressure at the base of the liquid will be maximum. C is the right option, sir. Okay, that is right. A swimmer is at the bottom of a pool. The density of the water in the pool is 1000 kg per meter cube, and the gravitational field strength is 9.8 Newton per kg. Which expression gives the pressure exerted on the swimmer due to water? The the pressure is rho GH, depth multiply density multiply the gravitational field strength, and its units will be Pascal. So let's see. So I think it looks B looks the right option, sir. B looks the right option. So let's see. Question number 13, B is the right option. I hope you understand. Okay, here we go. Question number 14. Some gas is trapped in a large syringe. The atmospheric pressure is 100 kilopascal. The gas pressure is 200 kilopascal above the atmospheric pressure. The piston moves outwards and the volume of the trapped gas doubles. The temperature remains constant. What is the new gas pressure. You see here, one thing is very important. The atmospheric pressure is 100 kilopascal. Okay. The gas pressure is 200 kilopascal above the atmospheric pressure. That means that the pressure of the gas is 200 kilopascal more than the atmospheric pressure. Atmospheric pressure is 100 kilopascal. So the pressure of the gas is actually 300 kilopascal. The volume has become double. The temperature is constant. So what is the new pressure? You see here the gas pressure, the gas, the temperature is constant. So the P1 V1 equals to P2 V2. That formula will be applicable here. So let me show you question number 14. So the pressure one of the gas, that is 100 plus 200, that is 300 kilopascal. So because the temperature is constant, and so we will apply this formula P1 V1 equals to P2 V2. So 300 multiply V, and P2 is question, and the V2 is whatever was the volume before, now it has become doubled. Before the volume was V, now it has become 2V. So even I will make the P2 alone, so it will be 300 divided by 2V, and V have been cancelled. So the P2 will be 150 kilopascal. 150 kilopascal. So the pressure 2 will be 150 kilopascal. So we think that B is the right option. Question number 14. B is the right option, sir. Question number 15. A graph of temperature against time is shown for a material being heated from its solid state. So which row describe what is happening at X, Y, and Z? You see it's a solid. So when the time is passing by, the temperature is increasing. Here, the temperature becomes constant, time is passing by. So most probably the solid is melting, and here the solid has been converted into liquid, and now its temperature is rising. And here I think that liquid is converting into its boiling, I mean. Sorry. So at X, the solid is melting. So melting is taking place. At Y, the liquid's temperature is increasing. And at Z, the boiling is taking place. I think D is the right option, sir. Question number 15, D looks the right option, sir. Question 15, D is the right option. Okay, so we are going to the next question. The next question is question number 16. A student on a camping expedition cools a sealed bottle of water, which is at the same temperature as the surrounding air. Which method cools the water at the greatest rate? Wrap the bottle in aluminum foil and place it in a shady place. No. Aluminum foil will prevent the exchange of the heat, okay? Wrap the bottle in dry white paper and put it in a sunny day. You know, if you want to cool something, don't wrap it in the white paper because the white is not a good emitter of the infrared radiation. Wrap the bottle in foam and put it in a breeze. Foam is an insulator, so it will prevent the exchange of the heat. Wrap the bottle in a wet paper and put it in a breeze. Yes, that is the right method. So when you wrap it in a wet paper and then you put it in a breeze, so what will happen? The evaporation of the water from that wet paper will take place, and the temperature of that bottle which is wrapped in that wet paper, that will decrease. So D looks the best option to me. So let's see. Question number 16, I think D is the option. Question 16, D is the right option, sir. Okay. So here we go. Question number 17. Okay. A student suggests three factors that affect the rate of emission of thermal energy by radiation from a hot object. These are the surface temperature of the object, that's true. The surface area of the object, that is also true. The surface color of that object, yes, temperature, which the heat which is given out, emission of the thermal energy, that depends upon all these three factors. Which suggestions are correct? So I think they all are correct. So I think A is the right option, sir. 1 is right, 2 is right, and 3 is also right. A. That's true. Okay, so we are going to the next question. That is question number 18. A plane mirror on a vertical wall forms an image of an object placed in front of it. Which characteristics describe the image? The image which is formed in a plane mirror, it's a virtual image, it's an upright image, it's you can say it has the same size as the object, its distance from the distance of the image from the mirror and the distance of the object from the mirror, they both are equal to each other. So I think D is the right option, virtual and upright. Question number 18, D. So I'm sorry because of internet, you know, the the recording stopped. So let's again, sorry for the interruption. This is due to the internet. So we were talking about the question number 18, and the image formed in the plane mirror is virtual and upright. Okay, so I think it's right now. Question number 18. So let's check. 18 is the D option. That is right, sir. Question number, now we are going to the 19. He says, we have. He says the diagram shows light traveling in air incident on the surface of a glass block. Some light is reflected and some light is refracted. Which diagram shows the reflection and refraction of light? So when you enter from air into the glass, remember this thing. Because the speed of the light will decrease, so the light will bend towards the normal. Okay, so the light will bend towards the normal. And this is about the refraction, and obviously some light will be reflected also. So when the light will be reflected, the angle of incidence and the angle of reflection, they should be equal to each other. Here, this diagram is not correct. The reason is the light is reflected inside the glass. So this reflection is wrong. Here, the reflection is right, but this refraction is wrong. Here, the angle of incidence, angle of reflection, they are right. But when the light entered into the glass, it bended away from the normal, which is wrong. In the glass, the light must bend towards the normal. So the D looks the right option, sir. Angle of incidence, angle of reflection, they are equal to each other. And here, when the light entered into the glass, it has bended towards the normal because the speed of the light in the glass becomes less. So it will bend towards the normal. So to me, D is the right option. Let's check. Question number 19. D is the right option, sir. Okay, so we are going to the next question, and the next question is question number 20. He says, which statement is correct? Total internal reflection only occurs when the light travels from air into the glass. Total internal reflection takes place when the light enters from a dense medium into a rare medium, not from air into the glass. The larger the refractive index of the glass, the larger is the critical angle. So just keep this option B. Let's check first of all A, C, and D. When the total internal reflection occurs, the angle of incidence is equal to the angle of reflection. The angle of, because when total internal reflection takes place, the reflection takes place. That's why the angle of incidence and the angle of reflection, they are equal. C looks right. Okay, when the total internal reflection occurs, the angle of incidence is less than the critical angle. No. When the total internal reflection takes place, the angle of incidence in the dense medium is more than the critical angle. Okay, so C looks very promising. When the total internal reflection occurs, the angle of incidence is equals to the angle of reflection. C looks a very, very promising answer. The larger the refractive index of the glass, the larger is the critical angle. We are not sure about it. And refractive index is equals to 1 by sine C. From that formula, you can think about this statement. But I think C is the one of the most correct answer. Here, I think C, question number 20, C is the right option. You see, this is the trick by which we pick up the right option. Okay, so here we have question number 21. He says, an object is placed in front of a converging lens of focal length 4 centimeter. The height of the image is 6 centimeter. The arrangement is shown in the scale diagram. What is the linear magnification produced by the lens? You know, the formula for the linear magnification is that the height of the image divided by the height of the object, the ratio of the height of the image to the height of the object. Another formula for the linear magnification is that the distance of the image from the optical center divided by the distance of the object from the optical center. So you can use any formula. Here the options are given. Okay, so we will have a look at these options. I have solved it. Question number 21. Height of the image divided by the height of the object. And from this diagram, I can show you what is the height of the image. Yeah, from here, you see 1, 2, 3, 3 centimeter. That is, they said that height of the image is, they said 6 centimeters. So that means 1 centimeter here is representing 2 centimeters actually. So if this is 2, 4, and 6 centimeter, so this is 2 and this is 3. Yeah. So this is 3 centimeter, this is 6 centimeter. Height of the image is 6 centimeter, height of the object is 3 centimeter. So I can find the linear magnification. Linear magnification is the height of the image divided by the height of the object. 6 centimeter divided by 3 centimeter, and that is 2 centimeter. This 3 centimeter, from where I got this 3 centimeter? I got this 3 centimeter from here. Here, this one big square is representing 2 centimeters. So the answer is 2. 2, let's check. Question number, which question was this? Question number 21, we think C is the option. Question number 21. Question number 21, I think C is the option. Question number 21, C is the right option, sir. Okay. Which range of sound frequencies includes only frequencies of sound that can be heard by a healthy human ear? You see, the healthy human ear can hear the frequencies from 20 hertz to 20,000 hertz. 20 hertz to 20,000 hertz. So this is not in that range because 0.5 hertz here. 5 hertz here, so that is not right. 50, yes, this is inside that range. 5,000, that is inside that range. So C is the option. The audible frequency range for the human ear is from 20 hertz to 20,000 hertz. So C are those in the C option. The frequencies are those frequencies which are in that audible frequency range. So we think C is the choice. Question number 22, C is the right option, sir. He says, and question number 23, an aircraft flying through the air becomes what electrically charged. What causes this to happen? You see, background radiation in the aircraft? No. Friction of the aircraft with the air? Yes. Heating of the aircraft surface? No. Radio waves emitted by the aircraft? No. So the actual reason is the friction between the body of the aircraft and the air. So I think B is the right option. Question number 23, B is the right option, sir. Question number we have here, question number 24, it says, two metal spheres are brought close to each other. The two spheres repel each other. Which statement explains this? If the two spheres who are made of metal are repelling each other, so most probably they will have the same charge on them. That's why they are repelling each other. Both spheres are charged and both are positive. That is true. That is, I think, the best thing. Both spheres are charged, but one is positive and the other one is negative. That is wrong. If they are oppositely charged, then they will attract. He says the spheres are repelling each other. Okay. The spheres have the same number of electrons. We don't know that. The spheres have the same number of protons. We don't know that. So one thing which is clear, because they're repelling, so they have the same charge. So A, question number 24A. Question number 24A is the right option, sir. So here we have question number 25 coming up on your screen. He says, a student sets up the circuit shown. The lamp does not light. What makes the lamp light? You see, why the lamp will not light up? The reason is because the conventional current is coming from this positive terminal. And when it comes here, this diode, because the conventional current is opposite to the arrow of this diode, so we say the diode is backward biased. And when that diode is backward biased, it do not let the charges flow through it. It will have very high resistance. So the lamp will not lit. So what makes the lamp light? Changing the supply to a 12-volt battery? No. Inserting a fuse? No. Reversing the battery connection? Yes. If you will reverse the battery connection, for example, negative come here, positive comes here, then the conventional current will come from here, and then the arrow of the diode and the arrow and the direction of the conventional current will be same. So then the resistance of this diode will be very low. It will let the charges flow through it. So I think C looks very good. And reversing the connection to the lamp, no. It will have, actual thing is this. C choice. Question number 25, I think C is the best option, sir. Yeah. Okay, now we have question number, wow. Question number 26. He says, circuit P and Q each contains two identical resistors, each of resistance R. What is the resistance of the circuit P and what is the resistance of the circuit Q? You see in this, because the resistors are connected in series, so their equivalent resistance can be found by simply adding them. So the equivalent resistance here will be 2R. Here, the resistors are connected in parallel to each other. So their equivalent resistance is 1 by R. Equivalent is equals to 1 by R plus 1 by R. So let me show you. I think I have solved this also. Question number 26. So let me show you. So when they are in the case P, the total resistance will be 2R. In the case Q, the total resistance will be R by 2. 2R and R by 2. I think C is the right option, sir. C. Question number 26. C looks the right option. Okay, so we are going to the next question. That is question number 27. The current in an electric motor is 2 ampere. It transfers 20 joule of energy in 5 seconds. What is the potential difference across the motor? You know the uh, potential difference is energy divided by charge. So the current is given, the time is given. You can find the charge, and the energy is also given. Then energy divided by charge, that will be. So voltage is equals to energy divided by charge. So Q is equals to current multiplied time. That is 2 into 5. That is 10 coulombs. So the voltage will be energy. That's 20 joules. And the charge, that is 10 coulomb. 20 divided by 10, and that will be 2 volts. So question number 27, 2 volt. B looks the option, sir. Question number 27, B is the right option. Question number 28. He says 3 students make comments about appliances with double insulation. Student P, appliances with double insulation do not need an earth wire. That is true because their bodies are made of plastic, so there is no need of earth wire because in their body the current cannot flow. Student Q, double insulation protects the user of the appliance from an electric shock. That is true. The student R, the circuits of appliances with double insulation do not contain fuse. No, they have fuses in them. So which statements are correct? The P and the Q statement is correct, and the R statement is not right. The fuses are, even the instruments which have double insulation, means their bodies of plastic, they still have fuses. So I think B is the right option. P and Q only, they are correct. So 28, B looks the right option. Question number 28, B is the right option, sir. Here we have a magnet moves, question number 29. A magnet moves at constant speed through a coil of wire. The coil is connected to an oscilloscope. The diagram shows the trace produced on the screen. So here you have this trace. You can see first it is negative in EMF. Then we have positive EMF. And the cycle has completed in 1 and 2 squares. And the amplitude in negative is 3.1, 3.2. In here also it is 3.2 something. The experiment is changed and a new trace is produced. Okay, now the amplitude is still 3.1 or 2, yeah, and amplitude here is also. But here first a negative was shown, then a positive. Here a positive is first and a negative is, then we have that negative. And the time to complete this wave has also increased. Here it is, this wave is completed in 2 squares horizontally. Here it is completed in 3 squares. So which statement explains why the new trace is different from the original trace? The coil, let me reduce the size. The coil is longer and the other pole of the magnet enters the coil first. That can be true. The coil is longer and the same pole of the magnet enters the coil first. No. The pole has changed because here, suppose this is first negative, here first is positive. The coil is longer and the same pole of the magnet enters the coil first. The B1 is 100% wrong. The coil is shorter and the other pole of the magnet enters the coil. I think the coil is not shorter because it has taken longer time. The coil is shorter and the same pole of the magnet enters the D is 100% wrong. So I think the coil is longer and the other pole of the magnet enters the coil first. I think A is the option. Question number 29, I think A is the option. And our answer is right. It's a little tricky question. Question number 30 is showing up on your screen. A bar magnet is dropped through a vertical solenoid that is connected to a sensitive ammeter. A current is induced in the solenoid and the solenoid becomes an electromagnet. Which row describes the polarity of the end Y of the solenoid and the force between the solenoid and the bar magnet when the bar magnet leaves the solenoid? When the bar magnet will leave the solenoid, so its south pole will be getting out of the Y. So that is the Lenz's law. The electromagnet which will be formed on the coil, it will try to stop that motion. To stop that south going downward, the Y will also become south. Okay? So it will try to attract it to stop the motion which is producing the electricity. That is Lenz's law. So I think on the Y, a south pole will be produced and it will try to attract the south pole. Sorry, because, sorry. Because when it will go through here, when it will be trying to leave, the south pole will be here. And on this coil, a north pole should be there. Because when it will be north and the south will be going away, so that north and the south, they will attract, they will try to oppose that motion. I made a mistake, okay? So here, north pole will be produced because the south pole of this bar magnet will be going away. To stop that motion on the Y, a north pole will be produced, which will be trying to attract that south. So a north pole and the attraction, I think A is the option. Let's check first of all then. Question number 30, A is the option. The option is right. Let me explain you again. You see, this is a bar magnet, which is going to pass through that coil. So when this magnet will leave from here, so when it will be leaving, its south will be on the top here, and that south is going away. To stop that, here a north pole will be produced on the Y to stop that motion. That is Lenz's law. It will be trying to oppose the motion which is causing the EMF in that coil. So I think A is the option, sir. Okay. Question number 31. Which graph shows the voltage output against time for a simple AC generator? In the AC generator, the graph goes above the mean position, then it goes into the below the mean position, then again it becomes above. So it's a sinusoidal wave. So it's a very simple thing. C is the right option, sir. Question number 31, C is the right option, sir. Yeah, simple, straightforward question. Here we have question number 32. A charger of a mobile phone, cell phone, uses a transformer which steps the voltage down from 230 volt to 5 volt. So the voltage in the primary are 230 volt and the voltage in the secondary are 50 volt. The primary coil in the transformer has 2500 turns. How many turns are on the secondary coil? Very simple, straightforward question, you know. The very famous formula, Vs by Vp is equals to Ns by Np. So 5 volt divided by 230 volt is equals to Ns, number of turns in the secondary is question, divided by the number of turns in primary, that's 2500. So just do this calculation. So you will have 5 into 2500 divided by 230, and your final answer will be 54.3. 54.3. 54.3. So 54 looks the best option, sir. Question number 32. B is the option. B is the right option. Here we have question number 33. A commutator is connected to the coil of a DC motor. The commutator rotates and connects the coil to the power supply. Once every half turn, the current in the coil reverses. What is the name of the commutator and what is the orientation of the plane of the coil as the current reverses? That is called split ring commutator. Split ring commutator. This is called split ring commutator. And the orientation of the plane of the coil, when the coil becomes vertical, after that moment, the current reverses. So the name of that component is split ring, and the plane of the coil is perpendicular to the magnetic field. When this happens, the direction of the current reverses in the coil. So I think D is the right option, sir. Question number is, oops, question number 23. I think D is the option. Question number 33, D is the right option, sir. Question number 34. A girl makes a simple transformer to illustrate a low voltage lamp, to illuminate, sorry, a low voltage lamp. The transformer is shown. Okay. So what is the material of the rod and what is the type of the power supply? You know, whenever we make the transformers, the power supply must be alternating. The transformers automatically work on alternating current. So in the primary coil, we always provide the alternating current. So the material of the rod, that core, that rod is made, must be of the soft iron. So the material of the rod must be iron, and the power which is supplied to the primary coil, that must be alternating current, AC current. Iron and the AC current. D. Sir, D should be the right answer. Question number 34, D is the answer. Yeah, that answer is right. So we are going to the next question. The next question is question number 35. It says, which particles are in the nucleus of a large atom? In the nucleus, we have protons and neutrons. So C choice, protons and neutrons only. Question number 35, C is the option. Yeah, that's true. Question number 36. Alpha particles and beta particles are emitted during radioactive decay. Which particles has the weaker ionizing effect and which has the weaker penetrating power? So the weaker penetrating power is of the alpha particles because of their larger size. They are like the nucleus of helium. They have very large size, so that's why their penetration power is very weak. And ionizing power is the alpha particles, they have very strong ionizing power, and the beta particles have relatively less ionizing effect. So the weaker ionizing effect is of the beta particles and the weaker penetrating power is of the alpha particles. So I think C looks the right option, sir. 36, C. Yeah. Question number 37. A beam of beta particles passes into a magnetic field and into an electric field. So, which numbers shows the path of the beam through the fields? You see, the beta particles are negative. Beta particles are negative. So you can apply the left hand rule. So you will stretch the fingers. You see, let me show you. Let me. Okay. So here, this is my left hand. So this is thumb, this is the index finger, this is the middle finger. So FMC, that's the force, that's the magnetic field, and this is the current. Okay. So strike them so such that they are mutually perpendicular to each other. So the magnetic field is going from north to south, and the charges are going into that direction. My thumb is pointing upward, but because this is left hand rule and this is applicable to positive charges, but these are beta particles which are negatively charged. So wherever my thumb is pointing, they will deflect opposite to it. They will deflect downward. Okay, in the magnetic field. Okay, so and then here in this part, you see, because the beta particles are negative, so they must be attractive to the positive plate. So 6 is the right option. Number 6 here. So 3 and the 6. So 3 and the 6 are the right options. Okay. So I think D looks the right option. I hope you understand. I hope you know how to apply the left hand rule. And because these are beta particles, they are negatively charged. The left hand rule is for the positive charges. So whatever your left hand rules, the thumb points the direction of the force in which the particle should be deflected. Because these are beta particles, they will be deflected opposite to that. So 3 and 6. D looks the right option, sir. Question number 37. D is the right option. Hopefully you understand. Question number 38. He says the isotope radon 222 has a half-life of 3.8 days. Which statement about a sample containing 1 milligram of radon is correct? He says after 1.9 days, there is 0.50 milligram of the radon 222 left. Okay, so half-life is 3.8 days. Okay, so after 3.8 days, there is 0.50 milligram of the radon 222 left. Yes, that is true, because 1 milligram after one half-life, it will become half. So let's say on 0 day, you have 1 milligram. When 3.8 days will pass by, its one half-life has passed. So this sample will become half, 0.5 milligram. This is the right option. Its half-life is half that of a 2 milligram sample. No, there is no radon 2 left after 7.6 days. No. So B looks the right option, sir. Question number 38, B is the right option. What is the first stage in the life cycle of stars? A black hole, that's the last stage of in the life of a star. A cloud of gas and dust. Yes, this is from where the birth of a star starts. Cloud of gas and dust. A red supergiant nova, supernova. No, these are the later stages of in the life cycle of a star. A cloud of gas and dust. This is from where the star birth starts. So I think B is the option. Question number 39. B is the right option, sir. So then we have here, these are the new topics, space physics. Okay, what is the definition of the redshift? You see, redshift means that the stars and the galaxies which are moving away from our galaxy, the light coming from those stars or those galaxies, when its light reaches on the earth, its wavelength increases, its frequency decreases. So it has redshift in it. The increase in observed frequency of the light from galaxies that are moving away from the earth, no, the frequency will decrease. That is redshift. The increase in the observed wavelength of the light from galaxies that are moving away from the earth, that is the right thing. This is the redshift. The light emitted by distant galaxies that is blue when it reaches the earth, no, it becomes red. The light reaching the earth that is red when it is emitted by the distant galaxies, no, when it is emitted from that galaxies, it is not red. but because that source of the light is moving away, that's why the light, when its light reaches the earth, it has redshift in it. So B is the right option. Question number 40, B is the right option. So, my dear students, we have completed this paper. Today we have done October, November 2023 1-1 paper. And I have tried my best to explain you the concepts, and hopefully this video will help you. If you like this video, if this video is helpful to you, please like this video, also subscribe my channel, and also share this video onto your Facebooks, onto your Twitter accounts, onto your TikTok accounts, and onto your Instagram, because that will help me to promote my channel, and that will help me to keep doing this work. Thank you very much. Have a good day. God bless you all.